Okay, so this problem says a regular pentagon is shown in the diagram below. So this is a pentagon, 5 sides. And then he goes on to say, if the pentagon is rotated clockwise, that means clockwise with the clock, like this way. Okay? Oh, I got you. If the pentagon is rotated clockwise around its center, the minimum number of degrees it must be rotated to carry the pentagon onto itself is. In other words, this is what happens. You're going to rotate the pentagon, and it will, when you rotate it, it will have to look exactly the same in the same position. Okay? Like that, clack, clack. So this vertex will be over here. This one over here, this one over here. So how many degrees do you have to really rotate it? Well, think of it this way. Think of it as this being the floor, right? Okay? And I'm gonna rotate it clockwise. So how many degrees do you have to really rotate it to go into itself? Well, if this vertex is going to be over here, okay, this is your angle right here. You have to rotate it this many degrees. But then how do I know? Well, easy. There's a formula that reads in the following way. 360 degrees, okay, divided by the number of sides will give you the angle. Okay? Why? Because we know that on the outside of any figure we have 360 degrees. So if we divide it by the amount of sides, it's going to tell us each of the angles of the outside. All right? So let's do it. So what is 360 divided by the amount of sides? Well, how many sides do we have? 5. It's a pentagon. So 360 divided by 5 is, okay, so let me do it like this. 360 divided by 5, the number of sides, is 72. So this angle right here has to be 72 degrees. Or if you already know how many degrees each angle on the inside has in a pentagon, then you know that this is a linear pair and they're equal to 180. So if this is 108, you know this is gotta be 72, right? So correct choice is number 2. Okay? Now, if you divide by the number of sides, you're gonna get the angle. If you divide by the angle, you're gonna get the number of sides. That's it. That's all you need. All right. So here we go with the next problem. So we have a diagram here, and it says, a reflection over which line does not carry the square onto itself. Carrying something onto itself means to leave it intact, untouched. That means that if you reflect it, it will still stay on the same coordinates. That's basically what it means. The coordinates will not change. So let's try x equal 5. The line x equal 5 is a vertical line where x is 5. So let's see now. This is 0, 0. So let's see. 1, 2, 3, 4, 5. If I reflect over this line right here, if I reflect this over this line like this, it will not carry itself. It will not carry the square onto itself. So therefore, this will not carry the square onto itself. But just for for the sake of continuing with this, let's try choice number 2. The line y equal 2. The line y equal 2 is a horizontal line. I know y you think is vertical, but no, it's not. If you actually look at it, it's saying whatever x is, y is always going to be 2. So for example, if x is 0, y is going to be 2. If x is 1, y is going to be 2. If x is 3, y is going to be 2. So you see the pattern is going to be a horizontal line. So basically this is the line, right? So if I was to reflect the square like this on this line, it will fall onto itself. You understand what I'm saying? So that's what it means to carry onto itself. So now that you understood, we know now that the correct choice is choice number 1, because it will not carry onto itself. All right, next question. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? Which polygon? Well, you could make a chart, say a triangle has 180 degrees, so therefore this is 60-60. Rectangle has, or a square has 90 degrees, okay, so the whole sum is 360. A pentagon is 540, and so on and so forth until you figure out which one has 45 degrees. But now the problem is that this is not 45 degrees, it's actually 135. Why? On the inside, if you get that shape. Because when you say a rotation of 45 degrees to carry into itself, we're talking about the exterior angle. So we're talking about that this is 45 degrees, therefore this is 135. Anyways, let's say you don't know, so then we just sum it upon the formula that I just showed you. The exterior angle, the sum of the exterior angles is 360. If we divide by the angle of rotation of the outside, like that, okay, then we end up with, well, what is 360 divided by 45? That's 8. 8. Now you need to know the names. An octagon has 8 sides. A decagon has 10 sides. A hexagon has 6 sides. A pentagon has 5 sides, as we just saw. So the correct answer is 8. Remember, angle of rotation to carry something onto itself. Oh, okay. Here, a parallelogram must be a rectangle when its diagonals are, well, quick explanation. A parallelogram, it's a shape that has, wow, this is not even straight. It doesn't matter. A parallelogram is a shape whose opposite sides are parallel. And what else do I know? Diagonals bisect each other, meaning that they meet each other at the midpoint, at the center, right? At the middle. That doesn't mean that the diagonals are congruent. Look, this diagonal is actually longer than this one. Oh, okay. So I only know, let's go over the choices. Remember, a square, hopefully, well, this is a rectangle. So what do I know about the rectangle? Diagonals are congruent and bisect each other, because remember, a parallelogram has opposite sides parallel and congruent. So yes, a rectangle is also a parallelogram. A square is also a parallelogram. So it's kind of like difficult. Now, in a square, okay, in a square, we have that diagonals bisect each other. Remember, if it's a parallelogram, diagonals will bisect each other. But in a square, diagonals are also perpendicular. Got it? Oh, okay. So what do I need to know? I need to know when is this parallelogram a rectangle. So let's go over the choices. Diagonals are perpendicular. No, I never said anything about being perpendicular on the rectangle. So this is not the answer. Diagonals are congruent. Yes, we know that the diagonals are congruent. Opposite sides are parallel. Listen, opposite sides are parallel on the rectangle, on the square, on the parallelogram. So no, opposite sides are congruent. We already said in a parallelogram, opposite sides are congruent. So no, it could be any of these shapes. So that's why number 2 is the right answer. Diagonals are congruent. Okay. Quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove that ABCD is a parallelogram? Okay. So basically, what is not sufficient to prove that this is a parallelogram? Therefore, I must look for the information that proves it that it is a parallelogram in order to know what proves it that it's not. So let me draw a parallelogram. Right here, 2 inches, and then 2 inches here. I mean centimeters, whatever. Oh, okay, so we got our parallelogram. And we're gonna label it A, B, C, D. So how am I gonna label it? Well, it says that diagonals AC and BD. So diagonals AC and diagonal BD. Look, diagonals AC and diagonals BD. Okay? So, first things first. What do I know about a parallelogram? Diagonals bisect each other. Okay? Opposite sides are parallel. Two pairs of opposite sides congruent. Okay. So now let's see. We're looking for what is not sufficient to prove that it is a parallelogram. AC and BD bisect each other. AC and BD bisect each other. That is a part of a parallelogram. So this is sufficient. What else? AB is congruent to CD. AB is congruent to CD. AB is congruent to CD. And BC is congruent to AD. And BC is congruent to AD. So these two are congruent and these two are congruent. Yes, in a parallelogram, two pairs of opposite sides are congruent. Okay. What else? AB is congruent to CD. AB is congruent to CD, yes. And AB is parallel to CD. And AB is parallel to CD. So let's see. They congruent and they parallel. Therefore, when you draw these two, they have to be parallel. Correct? But these are the ones, the order in which it says it, right? AB is congruent to CD. And AB is also parallel to CD. Because of the order. Let's try this one. AB is congruent to CD. These two are congruent. And BC is parallel to AD. And BC is parallel to AD. Confusing. These two congruent and these two parallel. Oh my God. Let me try something else. Let me try something else. How long is this? Okay, 9 to 11. I'm just gonna try 9 to 11. Okay, and now, boom, and now this, now this, for the sake of doing it. Okay, so once again, A, B, C, D. Okay, and I'm gonna draw the diagonals because something is not right here. So basically what I just did here was create a scenario where AB is congruent to CD. Okay, because that's what the last choice says. AB congruent. It doesn't say that they have to be parallel. And BC is parallel to AD. And BC is parallel to AD. Now it makes sense. You see, you have to look for a different format, a choice, a different option. And I just realized something. Okay, the way I had it, it makes sense right here. But when I looked at the other shapes that I know, okay, I know that in a trapezoid, and what gave it away? Because you have to follow the order. It says diagonal AC and diagonal BD. So now I realize something, that these two sides can be congruent. And these two sides parallel cannot prove that this is a parallelogram. Because there is another shape such that it is not a parallelogram that proves that it cannot be. Do you understand what I'm saying? So you have to look for other options. You have to actually be able to remember the shapes. So now we know that choice number 4 is not. If you had said that these two were congruent and parallel to each other, then that would have been a different story. So you got to remember the order in which they say it. Okay, so now let's move on to the next question. Oh, and it was a multiple choice, but hey, listen, you got to think about it. You got like 3 hours to finish that Regents. Okay. So what do I know now? Well, the following. It says, well, read it. it says in parallelogram, QRST is shown below, diagonal TR is drawn, right? U and V are drawn as well, right? Are points on TS. Okay? And QR. Okay? Respectively. And UV intersects TR at W. Okay. Now, mathematics. The measure of S is 60. This angle is 60. Okay. Angle SRT. SRT. This angle is 35 degrees. No. Despacito. I almost make a mistake, Cito. Alright, so it's 83. And measure of TWU is 35 degrees. Okay? 35 degrees. So now what? What is the measure of WVQ? WVQ. They want the measure of this angle right here. Not a problem. Let's think about it. What do I have? I have several shapes right here. That's what I have basically. So let's figure something out. I need to know this measure, and in order for me to know this measure, I need this other measure. And for me to get this measure, I need at least one other measure. So what do I know? Well, this is a parallelogram because that's what it says on the problem. So in a parallelogram, I know that same side, okay, or adjacent angles or consecutive angles, however you want to call them, that this angle plus this angle are supplementary. You see, this angle, not just this one. So that means that 60 plus whatever is 180. 60 plus what is 180? 120, right? So that means that this angle has to be 120. So that means that this angle is 37. All right, so now I know this angle. This angle is 37. I know that this angle is 35. Why? Because these two are vertical angles, and vertical angles are congruent. So that's 35. Okay, so that makes that 37 plus 35 is 72. That means that this angle in this triangle is 108 degrees, and I am going to start writing in ink again, of course, as soon as I find the pen. So this angle right here is 108. And I know that this angle plus this other angle are supplementary because they form a linear pair. So this must be 72. See that? So that means that our correct answer is choice number 3. But you see how I think about it? That's the same way you have to think about it. Degrees, sum, and all that. All right. What do we have here? In the diagram of wait, hold on a second. What are you doing, Bex? Now we're talking. In the diagram of parallelogram, Fred, 5 nights at Fred, shown below, ED is extended to A, and AF is drawn such that AF is congruent to DF. Okay, so what? AF is congruent to DF. AF is congruent to DF. Automatically, we know that it creates an isosceles triangle, and therefore this angle and this angle are congruent. Okay, but still. Then it says, if measure of angle R is 124 degrees, so this is 124 degrees. What is the measure of AFD? Measure of AFD. They want this measure right here. Well, think about it. Opposite angles, okay, opposite angles. Wow, they're knocking on the door. Opposite angles in a parallelogram are congruent. Therefore, or in other words, you could say the following. In a parallelogram, this parallelogram, consecutive angles are supplementary. That means that they are up to 180. So this plus this is 180, and this plus this, since they're consecutive, is 180. That's why opposite angles in a parallelogram are congruent. Now, guess what? If this is 124, then how much is this angle right here? Well, think about it. It's a linear pair. This angle plus this angle is 180. So then, what is the measure? Is 56. 56 degrees. And remember, this is an isosceles triangle, therefore base angles are congruent, so this is also 56. So now that we know that, then we know that we have 112 degrees right here. So now we can figure out what this one is, and this angle right here is 68 degrees. Okay? You could rewatch it again until you understand it. All right, let's move on to the next problem. Okay, so the diagram below shows parallelogram LMNO with diagonal LN. Okay, diagonal LN, I get it. Measure of angle, this one is 118 and this one is 22. Since they already labeled it, I'm not gonna read the whole thing. Now they wanna know why angle NLO, angle NLO, okay, is 40 degrees. Why is this 40 degrees? Well, actually, it's not that difficult to explain. So let us get going. Well, first of all, opposite angles in a parallelogram are congruent, right? So this is also 118. Now the sum of the angles in a triangle, okay, is 180. So 118 plus 22 is 140. So this angle has to be 40. All right? So that's it. Fine. Okay. So this is what I said. Opposite angles in a parallelogram, okay, are congruent. So measure of angle O is 118. Okay, and then I said the interior angles, okay, of a triangle, okay, have a sum of 180 degrees. So, or therefore, okay, the interior angles, okay, you know, is 180 minus the sum of these two angles is 40 degrees. But you see, you have to write the whole explanation. Okay, let's move on. Okie dokie. Here, the endpoints of one side of a regular pentagon are this. Okay, now we're talking about a pentagon, so I could just, you know, mimic one pentagon like this. Okay, and when they say the word regular means that all sides and angles are congruent. So the endpoints are at -1, 4 and 2, 3. That means that one of these is -1, 4 and the other one is 2, 3. That's all I know. So what's up? They are asking me what is the perimeter of the pentagon. The perimeter of the pentagon. How do I know that? Well, first of all, I need to know what the length is. Length, but how do I find out what the length is here? Oh my God! How do you find length when you have two order pairs? You use the distance formula. So distance formula is nothing more than, okay, what is that? X2 minus X1 squared plus y2 minus y1 squared. All right, and now I just have to replace. I'm sorry, I put parentheses. This is supposed to be equal. So let's see now. I got 2 points right here. So I'm gonna call these the ones and these the twos. Got it? So let's see now. x1, x2 minus x1, 2 minus negative 1. 2 minus negative 1, okay, minus negative, okay, minus negative. Minus negative 1 plus square plus 3 minus 4 squared. So 2 minus negative 1 is 3. 3 squared is 9. Okay, plus 3 minus 4 is negative 1. Negative 1 squared is 1. So 9 plus 1 is 10. So D equals to the square root of 10. Got it? All right then. So what's up? Well, the length of this side of the pentagon, this length is radical 10. Right? Radical 10. A pentagon has 5 sides, and if they're asking for perimeter, that means that we have to add all sides together. So basically, radical 10 plus radical 10 plus radical 10. In other words, 5 times the square root of 10. And now you know what the answer is. Cool? Alright, let's move on. So, right here. Oh my god, this is too much writing and reading. It says, in the coordinate plane, the vertices of RST are, and we have them right here. Prove that triangle RST is a right triangle. Okay? State the coordinates of P such that quadrilateral RSTP is a rectangle. Prove that your quadrilateral is a rectangle. The use of the axis below is optional. Hell no, it's not optional. I'm gonna use it. Alright? So, let's see now. Alright, let me plot the points. So, I'm gonna make this smaller. You already read it. You have the handout. So, I'm just gonna go over here. Okay, so what do I know? R is 6, negative 1. So 1, 2, 3, 4, 5, 6, negative 1. So this is R right here. Okay, what else do I know? S is 1, negative 4. Okay, first of all, this is R. S is 1, negative 4. 1, 1, 2, 3, 4. This is S. Now what else? T is negative 5, 6. T is negative 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's T. And then prove that the triangle is a right triangle. Okay, whatever. Where's my ruler? I don't know what I do with my ruler. Oh, found it. Okay, you got it? Alright, so prove that RST is a right triangle. So I can see that if I tilt this, I'm gonna see a right triangle right here, this being the right angle. But first, how do I prove that something is a right angle? Well, hello, perpendicular lines, meaning perpendicular slopes. Okay, so if I can prove that this line is perpendicular to this one, right, I can say that this is a right triangle. So let's figure out what the slope is. So let's go now. 1, 2, 1, 1, 2. No, this is not it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Ah, okay. So the slope of TS, okay. The slope of TS is 10 over 5. No, over 6, sorry. Right? 6, right? 1, 2, 3, 4, 5, 6. 10 over 6. Okay, 10 over 6. And now let's figure out the slope of SR. Well, oh, and this is negative because it goes down. Now let's figure out SR. 1, 2, 3, 1, 2, 3, 4, 5. 3 over 5. So the slope of SR is 3 over 5 positive. So are these slopes perpendicular? I don't know. Let's see. Negative 10 over 6 translates to negative 5 over 3. And the slope of this line is positive 3 over 5. It flips and it's changed the sign. Therefore, these are perpendicular to each other. You see? So then you have to write it. You have to write it down. All right. So now, I just proved that this triangle is a right triangle. Correct? Now, it says, state the coordinates of point P. Say the coordinates of point P such that quadrilateral RSTP is a rectangle. Prove that your quadrilateral is a rectangle. Oh my God. So now I need to make this a rectangle. So what do I know? Well, a rectangle is a parallelogram. And a parallelogram has opposite sides with the same slope and parallel. So that means that from point T, I will have to create another line segment with equal length, okay? And that follows the same slope. So in other words, I could just go like this. The slope from S to R is 1, 2, 3, 1, 2, 3, 4, 5. So I could just go like 1, 2, 3, 1, 2, 3, 4, 5. Okay? Like that. That's a rectangle. Now, the explanation right here is very lengthy. So what you're going to write is the following. You proved that it was a right triangle. Okay? Because the slopes of ST and SR are perpendicular. Got it? Now, to prove that this is a rectangle, okay, and state the coordinates of point P. Point P would be, this is 0, 0, so that would be 0, 9. So you write the coordinates of point P, okay, the coordinates of point P are 0, 9. Okay? And to prove that this is a rectangle, all right, here goes the heavy artillery. So let's see. How am I gonna do this? Okay, so we know that this is an angle. Okay, so this is what you're going to be writing. In a rectangle is a parallelogram. And all four angles in a rectangle are right angles. So since the slopes of TS and SR are opposite reciprocals, then angle S is a right angle. Okay? And now, in a rectangle, opposite sides are parallel. So that means that they have the same slope. So TP, since the slope of SR is 3 over 5, then the slope of TP has to be 3 over 5. Okay? To make them parallel. And now, since the slope of TP and the slope of RP, since ST and SR have opposite reciprocal slopes, then TP and PR have to have opposite reciprocal slopes. Therefore, the slope of TS and PR have to be -5 over 3 or -10 over 6. And the slopes of SR and TP are 3 over 5, both of them. Therefore, this RSTP is a rectangle. Okay? So that's basically what you write. I hope you understood it. Never mind this mark. Okay. It's a rectangle. Okay, let's move on to the next problem. Okay, so a quadrilateral has vertices with coordinates of, and you have the coordinates. Which type of quadrilateral is this? And you have the choices: rhombus, rectangle, square, or trapezoid. Well, you have to understand something. In order for you to actually do this, okay, you'll have to, okay, let's do this algebraically and then I'll show you the easy way. All right, I'm gonna have to write in pencil because I might make mistakes. First of all, 1, 2, 3, 4 sides. So what I'm gonna do is I'm gonna find the slope of this side and this side, okay, because you got 1 side, 2 sides, right? 3 sides, 4 sides. All right, so the slope here, the first slope between these 2 points, okay, between these 2 points right here. I'm gonna call these the 1s and these the 2s. You already know the drill. So let's see, y2 minus y1 is 3 minus 1 is 2. x2 minus x1, 0 minus -3 is 3. So the slope between these 2 points is 2 over 3. Okay, now let me find the slope between this point and this point right here, okay, this and this. So let's see now, or actually we could have just labeled it. All right, So this is the ones and this is the twos. y2 minus y1. 2 minus 1 is 1. 5 minus negative 3 is 8. So this is now 1 over 8. Okay, I don't see anything there. Now let me find the slope. Oh, que bruto. This and this is one side. This and this is a diagonal. Okay, so let's see now. You know what? Let me resort to what I said was going to be my last choice. So I am going to draw a little like graph paper, right? Just for the sake of doing it, right? Okay, so like that. Let's see now. I just want to have an idea of where the sides are. So negative 3, 1 is negative 1, 2, 3, 1 right here. Okay. 0, 3 will be 0, 1, 2, 3 right here. Okay. 5, 2. 1, 2, 3, 4, 5, 2, 1, 2. Okay. And then negative 1, negative 2. Negative 1, negative 1, 2 right here. Oh, okay. So let's see now what this is. Oh gosh, that's what it looks like. This looks like a trapezoid. Anyways, so I think I'm okay with this. All right, let me call this A, B, C, and D, okay? Just for the sake of. So negative 3, 1 is A, okay? 0, 3 is B. 5, 2 is C. And negative 1, negative 2 is going to be D. Now I know what I gotta do. So I calculated, this is what I calculated here. I don't know if I'm making sense over here, but everything, remember, I don't have the answer, so I have to think about it. I calculated the slope of AB, okay, from these 2 points, AB. Then 5, 2 is C. I don't need to calculate the slope from A to C, from A to C. You see what happens? Because it's a diagonal. In order for me to prove if it's a rhombus, rectangle, or square or trapezoid, I gotta look at the sides first, okay? At the slopes of the sides. If the slopes of opposite sides are the same, then the sides are parallel, okay? So let's see now. Let me calculate BC. So I know where BC is. This is B and this is C. Got it? So let me calculate the slope of BC. Well, BC, Y1, the ones and the twos. So Y2 minus Y1 is 2 minus 3. 2 minus 3 is 1, right? I don't need this slope right here. I really don't. So let's continue. Okay, so let's see now. BC, so 2 minus 3 is negative 1. And 5 minus 0 is 5. So the slope here is negative 1 over 5. Now, let me calculate. And I already know that, look, they have different slopes. So therefore, it cannot be a rhombus. It cannot be a rhombus because opposite sides have the same slope. And I already drew it. Look, oh my God. Okay, right here. It cannot be a rhombus because in a rhombus, opposite sides have the same slope. And this one seems that it doesn't. Okay. It cannot be a rectangle for the same reason. It cannot be a square for the same reason. So it has to be a trapezoid. Because look, the slopes, if it was a rectangle, the slope should be the same. Or at least when I calculate the slope of AB, right, and BC, they should have been perpendicular if it was a square or a rectangle. Because this side should have been this way, forming a 90-degree angle. So you understand what I'm saying? All right, cool then. All right, let's go on to the next problem.